All right, we'll plan to finish up the notes here in this video. We're on problem 21, and they want us to graph the function f of x equal 5x divided by x squared minus 1 by following the list of steps. Okay, so you're going to see a problem like this on the test and the quiz also. Okay, in part A, we want to write the equations of the vertical asymptotes for the graph of f. So, the domain, I know I can't divide by 0. So if I set the denominator equal to 0 and then I solve, x would be plus and minus 1. Don't forget about the plus minus there. So I can't use 1 or negative 1 as an input value because I can't divide by 0. So therefore, I'm going to have two vertical asymptotes, which are going to be at x equals 1 and x equals negative 1. Okay. Write the equation of the horizontal asymptote for f. Okay, so if I compare the degree of the top to the degree of the bottom, I have a degree 1 polynomial up top divided by a degree 2 polynomial down under. 1 is less than 2, right? So y equals 0 would be the horizontal asymptote. Anytime the degree of the top is less than the degree of the bottom, y equals 0 will always be a horizontal asymptote. Okay, make sure to write the equations as equations. Okay, so write x equal 1, don't just write 1. Y equals 0, x equals negative 1. Okay. Part C, we want to determine the points, if there are any, where the graph will intersect the horizontal asymptote. Okay, so a graph can cross an asymptote. That can and will happen. Okay, so the way to know that is if I set the function equal to the asymptote, and then I solve the equation. Okay, so let's go ahead and do that. We got 5x divided by x squared minus 1 equals 0. And if I multiply both sides by the denominator, 5x equals 0, then divide by 5, x is 0. Okay, so this graph will cross the horizontal asymptote. That's going to happen one time when x is 0 and y is 0. So even though I've got a horizontal asymptote on the graph, like I'm still going to want to make sure that 0, 0 is on the graph. Okay. In part D, we want to determine the intercepts for the graph and then sketch the graph. So we got to get the x-intercepts and y-intercepts here. To get an x-intercept, I need to let y be 0. Y and f of x are the same thing. So let the function be 0, and then solve for x. When you do that, you got 5x divided by x squared minus 1 equals 0. Now we have already solved that equation, right? We did that in part C. So this point here, 0, 0, that's also going to be the x-intercept. Okay? And to get the y-intercepts, we need to let x be 0. So when x is 0, I have 0 divided by negative 1 is 0. Okay, so 0, 0 is an intercept there. Okay, so I'll go ahead and plot that point 0, 0. And let's see, after doing that, I only know one point on the graph, which is very typical of these problems. Okay, now I know I've got two vertical asymptotes. They're at x equal 1 and x equal negative 1. Go ahead and make dotted lines there at those spots. And then we said there's a horizontal asymptote at y equals 0. Okay, so make a dotted line there. And now I got 3 sections to fill in. So I got the left section, a middle section, and a right section. The next thing I'm going to do is I'm going to plot points here just so I can get the full understanding of the graph. Okay, so right now, again, I only know one point on the graph, 0, 0. If I let x be 1/2, I'll get this middle section done here first. If x is 1/2, then I get negative 10/3 when I plug that into the function. Okay, So the point 1/2 negative 10/3, that'd be right about there, negative 3 1/3. That point is on the graph. Okay? And then we're going to take negative 1/2 next. So if x is negative 1/2 and I plug that into the function, I'm getting 10/3 as the y value. Okay, so the point negative 1/2 10/3, again, it's a little bit bigger than 3, that'd be about right there. That point is on the graph. Okay, so I know a point right about there, then here, and here. I got these asymptotes, so the graph has to flow with the asymptotes. So in the middle, it looks like the curve is coming down. The left vertical asymptote will be on the right side of it. And we'll be pulling away from that slightly. We'll go through the origin, and then we'll approach the right vertical asymptote. We're going to be approaching it from the left side of it, though. Okay, so something kind of like that is what we're looking at in the middle. Let me get the right section done next. So I need to select some more values here. If x is 2, let me plug that into the function. 5 times 2 is 10 divided by 4 minus 1 is 3. So I get 10/3 there. Okay, so the point 2 10/3 is about right there. Okay, that point is on the graph. And I'll just select one more value here on the right. If x is 3, and we plug that into the function, 5 times 3 is 15, divided by 3 squared is 9, minus 1 is 8. So I'm getting 15/8. 15/8 is a number that's just a little bit less than 2. Okay, so there'd be that point. And the graph has to flow with the asymptotes. That's why they're there, right? That the graph is going to get closer and closer to these boundaries, but it's not ever going to get there. So we only found the one and only point where the graph crosses the horizontal asymptote. That's at 0, 0. So on the right, the curve is going to be coming down. The right vertical asymptote will be on the right side of that. Pulling away from that slightly, we'll go through those points, and then we'll be approaching the horizontal asymptote from above it. Okay, so something like that is what we're looking at on the right. If I next take negative 2, I'll get the left side here. So if x is negative 2, we get negative 10 divided by 3 is negative 10/3. Okay, so there's the point negative 2, negative 10/3. And then if I take x to be negative 3, I get negative 15 divided by 8. Okay, so negative 15/8, that's a number that's a little bit less than negative 2. So negative 3, negative 15/8, that's about right there. Okay, and again, I got this these asymptotes here, right? So the graph has to flow with those boundaries. So I think for the rest of this, like we're going to be coming along, we'll be below the horizontal asymptote and pulling away from that slightly. We'll go through those 2 points that we plotted there, and then we'll approach the vertical asymptote on the left. Okay, so something kind of like that is what we're looking at for the rest of this. Okay. Let's take a look at problem 22 next. So in problem 22, we want to solve some equations. We got a rational equation, which is fancy words for a fraction, and then we got a radical equation. Okay. Now, whenever I have a rational equation, the first thing I would kind of try to do is to get rid of the fractional form there. Okay, and I'm going to multiply both sides of this by the common denominator of all the denominators. So x squared minus 4, that's going to factor as x minus 2 times x plus 2. I got an x minus 2 over here also. Let's go ahead and multiply both sides of this by x minus 2 times x plus 2. Okay? So when I do that, and then distribute x minus 2 times x plus 2 into these two terms inside the brackets, The x minus 2's will cancel. That'll leave me with the 4 that was up top, also this x plus 2 that's coming in. And then plus x minus 2 times x plus 2 times 1 is x minus 2 times x plus 2. And then on the right, x minus 2 times x plus 2, that's the same thing as x squared minus 4. So I got an x squared minus 4 divided by an x squared minus 4. Those are gone. And I'm left with 16 there on the right. Now I'm back on more familiar ground because I don't have any more fractions involved in this, which is nice. So let me distribute 4, and I'll FOIL this out. Next, so I got 4x plus 8 plus x squared, and then 2x minus 2x, that's 0 in the middle. Negative 2 times 2, that's minus 4 at the end, equals 16. Okay, and let me get everything onto the left. So I have x squared plus 4x. 8 minus 4 is 4. And then when I subtract 16, 4 minus 16 is negative 12. That's all equal to 0. Okay, and this should factor nicely. If I have x and x, use 6 and 2. Okay, that'd be a plus 6 and a minus 2 for the signs. So if I check that, x times x squared, negative 2x plus 6x is 4x in the middle. That's good. And then 6 times negative 2 is negative 12 at the end. That looks good. So then set each of these expressions equal to 0. X plus 6 equals 0 means that x is negative 6. X minus 2 equals 0 means that x is 2. Okay. Now, one thing that you always have to do whenever you're solving a rational equation is you got to check your answers, okay? Because we can sometimes end up with these extraneous solutions. An extraneous solution is a number that came up that's not actually an answer, okay? So at this point, like negative 6 and 2 may or may not be the right answers. I don't know. I got to check. So if I plug in 2 into the original equation, always plug the numbers into the original equation, then that's a problem, right? If I plug in 2, I know I can't divide by 0. Okay, so 2 would be an extraneous number. Throw that number away. And then we want to know, is negative 6 going to be a solution? So same deal, I plug in negative 6. I got 4 divided by negative 6 minus 2 plus 1, okay? That'd be negative 4 over 8 plus 1. Negative 1/2 plus 1 is 1/2. Okay, and then do I also get 1/2 on the right side if x is negative 6? Well, I have 16 divided by negative 6 squared is 36. Minus 4 is 32. 16 over 32, that's 1/2. 1/2 equals 1/2, that's true. So negative 6 is going to be the only answer there on that problem. Okay. Now your book likes to give problems that have extraneous solutions. Okay, because guess what students don't do? They don't bother to check their answers. And you absolutely have to check your answers with these kind of equations. There's only 3 equations in all of algebra where you have to check your answers. They are a rational equation, a radical equation, this guy here, and then a logarithmic equation. We're going to look at logarithmic equations in the next chapter. Okay? So then that's part A. Part B, I want to solve the equation, the square root of 3x plus 7 equals 3x plus 5. Let's solve for x. Well, the first thing is to get the radical expression, which is the square root of 3x plus 7, all alone and on the left. We've already got that. Okay, and then now I want to get rid of that square root sign. So let's get rid of that by squaring both sides. The square root of 3x plus 7 squared would be 3x plus 7. And that's equal to 3x plus 5 squared. That's the same thing as 3x plus 5 times another 3x plus 5. And if I FOIL out the right side, I have 9x squared, 15x and 15x is 30x, plus 25. Okay, and let's get everything onto the right. So if we subtract 3x and subtract 7, we got 9x squared. 30x minus 3x is 27x. And then 25 minus 7 is 18. That's all equal to 0. Now I can make the numbers a bit nicer by dividing both sides by 9. I got x squared plus 3x plus 2 equals 0. That's going to factor as x plus 1 times x plus 2 equals 0. So then if I set each of these factors equal to 0, I get x equal -1 and x equal -2. I have to check those though, okay? So let's go ahead and plug each of these two numbers into the original equation and check and see if we're keeping them or if we're getting rid of them. I'll take -2 first. So if I plug in -2 into this, on the left, 3 times -2 is -6, plus 7 is 1, and 3 times -2 is -6, plus 5 is -1. So we're saying 1 equals -1. That's not true, right? 1 does not equal -1. So that means that -2 would be an extraneous solution. I'd want to throw that number away. Okay, and now let's check if -1 is going to work out. So same deal, we'll plug that into the equation there. 3 times -1 is -3, plus 7 is 4. The square root of 4 is 2 on the left. And then on the right, 3 times -1 is -3, plus 5 is 2. 2 equals 2, that's true. And so because that's a true statement, I'm going to keep -1. I'm going to get rid of -2. Now, by the way, I have no idea what number or numbers I'm going to keep or get rid of like before I even solve this. Okay, the main thing is that I got to make sure that I remember to check my answers though. Okay, because guess what students don't do? They don't bother to check their answers. Okay, but again, for these kind of equations, we have to check our answers. Okay. All right, so that's it with that section there. And we'll go ahead and stop the video right here. And in the next video, we'll get to start into chapter 4.